Synchronous motor. The synchronous motor is an electric motor whose rotation speed is synchronized with the electric frequency of the alternating current, and it is used in different fields where high precision is necessary. In this video, we will explain how this type of motor works. JAS, for over a decade, has been providing its customers with the best solutions for their supply chain, and in their catalog, you can find any kind of synchronous motors from leading manufacturers. Let's see how a synchronous motor is made. The coils of the stator, that is, the stationary part, are powered by a three-phase electric power of alternating current. In this way, they produce a rotating magnetic field that rotates a fixed speed related to the power frequency. On the other hand, the coils of the motor, the rotating part, are powered by direct current, hence producing magnetic fields of alternating polarity, like magnets. That's why the rotor can also be made with permanent magnets. The opposite poles of the stator and rotor attract each other in such a way that the magnetic field of the stator rotates and attracts the rotor, forcing it to rotate at the same speed. This is a peculiarity of synchronous motors. They operate at synchronous speed, a constant speed given by the electrical frequency of the alternating current and by the number of pairs of rotor poles. Motors with more coils in the rotor and stator have lower speeds but develop more mechanical torque. These features make the motors unable to accelerate or decelerate. Moreover, it is unable to withstand significant motor loads. In fact, if the motor is in motion and it is accelerated or braked by external forces, the two magnetic fields fall out of synchronization, causing the rotor to stop. If, instead, the rotor is stationary, the rotating magnetic field won't start the rotor because the attractive and repulsive electric fields alternate too quickly. In order to overcome these problems and improve the motor, a squirrel cage was introduced above the rotor coils. During the starting phase, the rotor coils are not energized. Therefore, the rotating magnetic field induces electricity into the squirrel cage bars, as in an induction motor. Once the synchronous speed is reached, the rotor coils are energized and start working again as a synchronous motor. If you are interested in learning about how the induction motor works, watch our previous video. Another characteristic of the synchronous motor is that it has the same constructive characteristics of an alternator. For this reason, it is used by electric and hybrid cars, usually in the configuration with permanent magnets, so that it can function both as a motor to give power to the driving wheels and as an alternator in the regenerative braking phase, to recover kinetic energy and transform it back into electrical energy to be stored in the battery. Watch our electric car and hybrid car videos to see how the synchronous motor is used. In the last few years, thanks to the improvement of electronics, starting an electric car is massively simpler. In fact, components such as inverters can modify both the frequency and the power supply voltage. As a result, starting from zero frequency and increasing it gradually, it is possible to accelerate the engine from a standstill, thanks to electronic speed control systems. Follow our lessons on electronics to learn about inverters, transistors, and all types of electric motors that we use every day. If you found this video useful, let us know by leaving a like and a comment. Also, you can share it. And don't forget to subscribe to our channel. We suggest you visit our website, jascompany.com, to know more about our next projects.